Let's see part 12, of ionic equilibrium. So 12 is question number 29. So solubility of mx2 of type electrolyte is given mole per liter. So its S value is given, that is 0.5 into 10 raised to minus of 4. Then find out the solubility product. Then you have to find out Ksp value. So see, very simple. When it dissociate, it forms M2 plus. So mx2, it dissociate to form M2 plus 2x minus. Right. So its solubility will be S and this will be 2S. So Ksp formula will become then S raised to 1 into 2S raised to 2. Right. So it will be S into 4S square. So it will be 4S cube is equal to Ksp. Right. So it will be 4 into S value we know, that is 0.5, 10 raised to minus 4. 0.5 into 10 raised to minus 4. Right. So raised to 3. So it will be 4 into how much? That will be 0.125 into 10 raised to of minus 12. So calculate it, you will get solubility product as 5 into 10 raised to minus 13. That is equal to Ksp. So please write it down. Now see the question number 30. Solubility of M2S. It is M2S. Right. Is given. That is 3.5 into 10 raised to of minus 6. Then find out solubility product. So when M2S is there, then it will dissociate into 2M plus and S2 minus. So it will be 2M plus S2 minus, right? So this will be the 2S, this will be S. So solubility product will be 2S raised to 2 into S raised to 1. So it will be 4S square into S. Then it will become 4S cube is equal to Ksp. So you have to find the solubility product. So it will be 4 into 3.5 into 10 raised to of minus 6 raised to 3. So calculate its solubility products. So you will get in the final 1.7 into 10 raised to of minus 16. Please write it down. Next one is 31. So see solubility of saturated solution of calcium fluoride. So calcium fluoride is CaF2, right? So its solubility is given S value. So that is 2 into 10 raised to of minus 4 mole per liter. So it dissociate into Ca2 plus 2F minus. So it will be S, this will be 2S. So solubility product will be S raised to 1 into 2S raised to 2. Then it will be S into 4S square. So it will be 4S cube is equal to Ksp. So it will be 4 into 2 into 10 raised to of minus 4 raised to cube. It will be 4 into 8 into 10 raised to of minus 12. So it is 32 into 10 raised to of minus 12 Ksp. So it is asked in 1999. Now see the question number 32. Physician wishes to prepare a buffer solution, right? So there is a physician who want to prepare the buffer solution whose pH is given. that is 3.58, that efficiently resists to change in pH yet contain a small concentration of buffering agents. Which one of the following weak acid together with the sodium salt would be best to use? Right, so it is weak acid together with sodium salt. Sodium salt. So see the 32 explanation. According to Henderson equation, we know the formula like pH is equal to pK plus log of concentration of salt by concentration of acid. So now to restrict the small change of buffering agent, to restrict the small quantities of buffering agents, concentration of salt should be equal to the concentration of acid. So this Henderson equation will be reduced in the smaller quantities like this. So this equation will be reduced as pH is equal to pK plus log of salt upon acid. So these are concentration are equal. So it will become 1. So it will be pH is equal to pK. Log of 1 is 0. So pH should be equal to pK a value, right? So we know the value, that is 3.58 given, right? So the series base should be having pK value, and right, so it will be equal to pK. So hence fit weak acid, which should be acetoacetic acid. So this will come under the range of acetoacetic acid. So please write it down. Now see the question number 33. So 33 is more about solubility product of copper sulfide, cadmium sulfide, mercurous sulfide are given. So solubility product like KSP is given of this compound. So it is 10 raised to of minus 31. It is 10 raised to of minus 44. 10 raised to minus 54. Right. So solubility of these sulfides are in the order. So you have to find the S value. It is solubility. So one by one, you have to calculate the S value of each compound. So here we can conclude the conclusion also. Higher the value of solubility product of the salt, higher will be the solubility. So S is directly proportional to KSP, right? As we know. So the more the S value, more the solubility product, more will be the solubility, right? So you can just observe lower value will be the higher, right? So this one comes and first in the race, this will be in the second, this will be in the third. So your order will be like this. So CUS will be the first, next decreasing will be CDS, next will be HGS. So this is the order for solubility. Next sum is 34. The hydride ion H minus. H minus is called hydride ion. Is a stronger base. So it is your stronger base. Then is hydroxide ion. Then OH minus. This is called hydroxide ion. Which of the following reaction will occur if sodium hydride is dissolved in water? So NaH, So NaH, sodium hydride, is dissolved in water, right? So see, it is dissolving in water. So see, this will be the Na plus and this will be H minus. In metal hydride, hydrogen is in minus position, right? So, and this will become nothing. H2O will dissociate into H plus OH minus, right? So this Na plus will attract this OH minus, right? And this hydrogen minus and this H plus will combine to form the hydrogen gas, right? H2. And another product will be NaOH. Understood? So this will be the reaction. So in the term of the reaction, it can be represented as like this. Suppose H minus is there, right? It is reacting with water to form the OH minus and hydrogen gas. So in this reaction, hydride ion accept a proton from the water to give the hydrogen gas. So please write this explanation. Now see the next sum, that is 35. pH of blood doesn't change appreciably by a small addition of acid or base because the blood is. So it is talking about blood pH, what it should be the pH precisely. So see here, serum protein in blood acts as buffer solution, right? So in blood there is serum protein which acts as buffer solution. That restricts the change in pH. That restricts the change in pH of blood after addition of a small amount of acid and base. After addition of small amount of acid and base. Now see the next sum, that is 36. Which of the following is most soluble? So it is talking about the solubility. So see the first, salt which has highest KSP. So salt which has higher value of KSP, solubility product, must be soluble, right? So it will be soluble, right? So MnS has highest KSP value. Magnesium sulfide has KSP value is highest. So among all these salt, it will be most soluble. So you can see in the option whose value is given, that is 7 into 10 raised to minus 16. So this is the highest value. So it will be more soluble. It is asked in 1994. Now see the next sum, that is 37. In which of the following solubility of silver chloride will be minimum? Right. So see the 37. So when silver chloride dissociated from Ag plus Cl minus, and when NaCl is there, it dissociate to form Na plus Cl minus, right? So due to the common ion effect, so Cl minus is common, right? So due to common ion effect, Cl minus, the equilibrium of dissociation of AgCl shift in the backward direction. So due to the more ion, due to Cl minus, uh, equilibrium will be shifted towards the left side, right? Dissociation constant is shifted in backward direction, right? Which decreases its solubility, which decreases its solubility. So please write it down. So answer will be the C option. NaCl having common ion, right? So this comes under the option C. Next is 38. 0.1 molarity solution. Which of these substance will be basic? So C. So first is sodium borate is given. So formula will be Na2B4O7. This is sodium borate. When it react with water 7H2O, it forms 2NaOH plus 4H3BO3, right? So sodium borate is a strong base. This is weak acid. This is again a strong base. Right. Now see the next one, that is calcium nitrate. Calcium nitrate. So its general formula is CaNO3 2 times. It dissociate in water to form the CaOH2 plus 2HNO3. Strong acid. Right. Calcium nitrate is weak acid. Now see the next, when it dissolved in water, like ammonium chloride, that is NH4Cl, when dissociate into water, it forms NH4OH plus HCl, a strong acid. So this is your weak base. Again, Na2SO4 is there. When it react with 2 moles of water, it forms 2NaOH plus HCl. No. When sodium sulfate dissolved in water, it forms NaOH plus H2SO4 now, because sulfate ion is there. So it will be H2SO4. So this is a strong base, strong acid. So sodium borate solution will be the basic, right? So this will be the next previous one, this one, sodium borate. So this is your basic, strong base will have the basic, while this one is acidic solution. And due to this one also, this will consider as basic solution, right? And next one is calcium nitrate, and this is acidic nature. So this will be the acidic. And next is also, this is your also strong acid there. So it is also exist in acidic nature. Right. So next one is basic. So it is a strong base and a strong acid. So it will be the neutral. So please write it down. Now see the question number 39. Compound whose aqueous solution has the highest pH. So it is talking about highest pH of the compounds given to you. First is NaCl. When dissolved in water, it forms NaOH plus HCl. Right. So this is a strong basic salt and this is a strong acid. Right. So net solution is neutral due to the strong. This combination will be the neutral. Next is NaHCO3. So when react with water, it forms NaOH plus H2CO3. This is a strong base. This is weak acid. Right. So next one is sodium carbonate Na2CO3 plus H2O. This is a strong base, react with water it to form 2NaOH plus H2CO3. From 1 mole and 1 mole of H of 2 is produced, 2 moles of N is formed. Thus the aqueous solution of this one is more basic, right? So you can just observe it here. In this case, sodium carbonate producing 2 moles of NaOH. So this is more basic, right? Due to the 2 moles of NaOH, and this is producing 1 mole. So this will be the less basic, right? So next one is ammonium chloride. When react with water, it forms NH4OH plus HCl. This is weak base. This is a strong acid. So the net result is acidic in nature. So it is acidic in nature. So which is having highest pH, which is producing more 2 moles of NaOH. So this will be the answer. This one, previous one. This is the answer because it is producing 2 moles of NaOH now. That's why. So pH will be more than 7.